Morning, everyone, and thank you so much for joining us today as we are here to discuss NASA's SpaceX Commercial Resupply Services mission, the 33rd, for our pre-launch teleconference, as the mission is slated to launch in the early morning hours this weekend. I'm Joseph Zakshesky with NASA Communications, your moderator for today, and joining us to discuss this mission and launch are Bill Spetch, Operations Integration Manager of the International Space Station Program, Heidi Paris, Associated Program Scientist, NASA's International Space Station Program Research Office, and Sarah Walker, Director of Dragon Mission Management, SpaceX. For those that are tuned in and on the media bridge, if you wish to ask a question to our media participants, please use *1 to ask your question, or use *2 if your question has already been addressed and you wish to withdraw. We'll start things off with opening comments from our briefers and head into the media question and answer session. And with that, I'll turn it over to Bill Spetch.
All right. Good morning, and thank you again for all of you joining us today to discuss this upcoming cargo resupply mission to the International Space Station. SpaceX 33 is targeted to launch at 2:45 a.m. Eastern Time on Sunday, August 24th from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida, and scheduled to dock to station on Monday, August 25th at about 7:30 a.m. Eastern Time. It'll be filled with more than 5,000 pounds of supplies, as well as a very important new capability to provide reboost for the ISS. NASA contracted with SpaceX a few years ago to provide a reboost capability to the space station. As you know, the space station's altitude slowly decays over time due to the thin amount of atmosphere still at our altitude. To counteract that drag, we must occasionally raise the altitude of the ISS. ISS has used a number of assets to maintain its altitude over the years, with the Russian segment providing primary propulsive support, supplemented by the Space Shuttle, the European Space Agency's ATV, and more recently, Northrop Grumman's Cygnus spacecraft. With the addition of the boost trunk on this mission, Dragon will also provide this ability to maintain the station's altitude. The hardware located in the trunk of Dragon contains an independent propellant system separate from the spacecraft to fuel two Draco engines using existing hardware and propellant systems design. The boost kit will help sustain the orbiting lab's altitude starting in September with a series of burns planned periodically throughout the fall of 2025. You guys might remember as well that during NASA SpaceX's 31st commercial resupply services mission, the Dragon spacecraft performed a very small demonstration of capabilities using just the capsule. That was on November 8th of 2024. The Dragon spacecraft is scheduled to remain at the space station until December, when it will depart and return to Earth with research and cargo splashing down in the Pacific Ocean off the coast of California. In addition to food, supplies, and equipment for the crew, Dragon will deliver several new experiments, including bone-forming stem cells for studying bone loss prevention and materials to 3D print medical implants that could advance treatments for nerve damage on the Earth. Dragon will also deliver bioprinted liver tissue to study blood vessel development in microgravity and supplies to 3D print metal cubes in space. Heidi will give you a more detailed explanation of the great science that's coming up on this mission. This resupply also consists of a lot of food for the crew. We have 129 of our standard menu bulk overwrap bags. I'll talk a little bit more about it in a bit, but 14 of those are specifically just to deliver tortillas. There are also 33 crew-specific menu bulk overwrap bags. We won't talk, obviously, specifics of that for the crew's privacy's sake. And then, of course, 18 coffee and tea preference bags. And, of course, very important, as we do on the ground, we like our caffeine. On orbit, the crew does as well, so the coffee tea is very important resupply for them. This mission, SpaceX 30, marks the first time that tortillas now have their very own bulk overwrap bags. Instead of being tucked into other food categories, this mission is actually delivering 14 dedicated tortilla bobs, carrying a total of over 1,500 tortillas to fuel future crew meals in orbit. We fly tortillas because there are other breads and things like that have too many crumbs and things of that nature, so you can't actually maintain it in orbit, and tortillas are a great substitute for that. This fall is continuing an incredibly busy time for the ISS, with 4 vehicles arriving in just a few months. We just started off with Crew 11 arrival on August 2nd after launching from NASA's Kennedy Space Center. After a brief handover, Crew 10 returned to Earth after 146 days aboard the space station. Next up, after we get through SpaceX-33, we will have Progress 91 undock, and then Progress 93 launch and docking in September, followed very closely by Northrop Grumman's NG-23 mission, launching in mid-September. Next on the docket, in October, and actually just recently announced by JAXA, the launch date of October 21st in Japan, October 20th here in Houston, will be the first ever HTV-X mission coming to ISS. And then finally, we'll get into November and welcome NASA astronaut Chris Williams as part of the Soyuz MS-28 in that November timeframe. We're getting close to the point in time where we get to celebrate 25 years of continuous human presence on board the ISS. If you reflect on the past 25 years on station, advancing scientific knowledge and demonstrating new technologies that enable us to prepare for human exploration of the moon as we prepare for Mars, the station's design requires humans living on board to maintain, operate, and upgrade it. So our commercial crew missions are essential to keeping that going. Through SpaceX Dragon crew rotation missions like Crew 11, NASA continues to maximize the important research, technology, and demonstrations possible only in the International Space Station's unique microgravity environment. I'll throw in our cargo missions are the key to keeping that going and fueling that as well. The ISS is critical for NASA to prepare for future commercial low Earth orbit destinations and to understand and overcome the challenges of long-duration spaceflight necessary for a long-term presence on the moon and missions deeper into the solar system, including Mars. Thank you again for your interest in the U.S. space program and the ISS program in particular. And a big thanks to all of the folks here at NASA and at SpaceX who come together and do a ton of work to make missions like this successful. With that, I'll hand it over to Heidi.
All right. Thank you, Bill. Well, good morning, everyone. Thanks so much for joining into the telecon today. I am super excited to get to talk with you a little bit more about all of the fantastic new science that we're bringing up to the International Space Station on this SpaceX-33 cargo vehicle. As Bill mentioned, we're coming up on a very special milestone for the International Space Station, and that's 25 years of continuous human presence, as well as continuous microgravity research on board our orbiting laboratory. Over that 25 years, we've hosted more than 280 residents. We've enabled more than 4,000 different scientific experiments and technology demonstrations, and that represents the work of over 5,000 researchers from over 110 countries around the world. The International Space Station is truly a very global endeavor, and it serves as a proving ground for scientific breakthroughs and also as a critical stepping stone to help enable the Artemis program, lunar exploration, and future Mars missions. So the SpaceX-33 Cargo Dragon spacecraft specifically will be carrying the hardware and samples to support right around 50 different scientific studies and research facilities. And I want to highlight just a few of those in a little more detail today. So first up is an investigation called MABLE-B that is studying the fundamental mechanisms behind the really significant bone loss that astronauts experience during long-duration spaceflight. So this research team is testing out the hypothesis that blocking a certain protein in the body that is known to promote bone loss or bone health changes may actually help reduce the overall bone loss that astronauts experience in space. If it's successful, the study could greatly improve astronaut bone health during the long-duration transit to and from Mars in the future. In addition, the knowledge that we gain from this study may also help us find ways to minimize bone loss in patients on Earth who suffer from things like osteoporosis and from certain types of cancers. The next investigation I want to highlight is sponsored by the European Space Agency. It's called Metal 3D Printer, and it's testing the viability of printing 3D metal components in microgravity. So this investigation also represents a capability absolutely vital for future exploration to the moon and especially onto Mars, where resupply options are going to be limited or in some cases non-existent. And so we really have to be able to make do with whatever we have on board already in order to make tools or spare parts. Once these metal components are printed on ISS, they'll be returned to the Earth for in-depth analysis of their quality, strength, and performance in order to help identify really the optimal approach for 3D metal printing in space. We also have an investigation that is using the advantages of the microgravity environment in order to study a different type of 3D printing in space, and that's 3D bioprinting. So this investigation, called InSpa Auxilium Bioprinting, is looking to create a 3D printed implantable medical device that can support nerve regrowth after injury by bridging the gap to reconnect severed nerves while also simultaneously delivering drugs that can support nerve regeneration. 3D printing these devices in microgravity actually eliminates the particle settling that we see on the ground, and it makes it possible to manufacture more uniform and more stable structures in a way that we really can't reproduce on Earth. And then the last one I'll highlight today is an investigation called MVP Cell 07. And this is studying whether microgravity can improve the formation of blood vessels and capillaries in a 3D printed liver tissue construct. So 3D bioprinting of tissues and organs is one of those areas with very wide-ranging applications in the medical industry, both as a tool for medical research as well as for potential organ transplant in the future. Developing a functional vascular system in that 3D printed tissue or organ is critical to being able to maintain the viability of that system by delivering oxygen and nutrients and then removing waste. And researchers think that the microgravity environment may be able to help improve both the distribution of the blood cells in a tissue as well as the development of the blood vessel wall linings in that tissue. So these are just, a few of the investigations we have launching on SpaceX 33 this weekend. If you'd like more information about any of these experiments or any other research that we're currently doing on board the space station, I encourage you to visit our ISS Research and Technology webpage at nasa.gov/ISS-science. Or you can also follow us on X at @space_station for updates on the current research that's being performed. All right, and with that, Sarah, I'll hand it over to you.
Okay, thanks. Well, as you've already heard, early Sunday morning, SpaceX teams will be launching CRS-33 to the International Space Station. Not only is this our 6th Dragon mission and 5th to the orbiting laboratory this year, it's also our overall 50th Dragon to go to the International Space Station to date. So Dragon first visited the station back in 2012 in support of the COTS-2+ mission, becoming the first private spacecraft in history to reach ISS. So COTS stands for Commercial Orbital Transportation Services, and it was the predecessor to CRS with a handful of demonstration missions before we began the regular resupply missions. We called this mission to ISS COTS-2+ because originally the COTS program had planned for 3 demonstration flights. One was just supposed to reach space and orbit the Earth a few times before coming back. One was to fly to the ISS and fly a circle around it to demonstrate proximity operations capability. And then a third would actually come in and rendezvous with the ISS. But NASA agreed on a conditional combining of that second and third demonstration missions, that if we successfully completed that ISS circumnavigation and the margins all looked good, we could proceed into the third mission's objective to rendezvous before flying all the way back home, so hence COTS-2+. So back then, Dragon was birthed to the space station rather than autonomously docking like it does today. Berthing is a term we use to describe Dragon flying a few feet away from ISS, kind of flying in tandem or in parallel, and then it's caught by the space station's robotic arm and pulled in the last few feet. So you may remember that mission when Don Pettit called down over the voice loop, "Mission Control, we've caught a Dragon by the tail." And how neat that he just came home from his most recent visit to ISS on his 70th birthday, almost 50 Dragon missions later. I certainly remember those words from my headset in Mission Control because it was the first Dragon mission that I worked at SpaceX. And since then, we've flown over 30 commercial resupply missions. We've flown demonstration missions of both our cargo and our Crew Dragon vehicles and 15 human spaceflight missions, including Demo 2 and all 4 Axiom space missions. Less than a month ago, we launched Crew 11, and with CRS-33, we'll mark our 50th voyage to ISS. Just incredible. Together, these missions have flown well over 300,000 pounds of cargo and supplies to the orbiting labs and well over 1,000 science and research projects that are not only helping us to understand how to live and work effectively in space, as Heidi was talking about, but also directly contributing to critical research that serves our lives here on Earth. She mentioned several experiments going up on this vehicle that will be doing that. Something I learned recently, did you know that cancer cells, their cell walls unbound by gravity, can grow many times faster in space than on Earth? Peggy and the Axiom 4 crew were just back at SpaceX headquarters for a post-flight visit, I think last week, and she was sharing with me over lunch that much of the research that they did during their mission earlier this summer was actually focused on this cancer research, and the NASA crews have done quite a bit of it as well over the past few years. The ISS is conducting groundbreaking and life-saving research every day, and quite possibly getting us to cures for diseases that ail us here on Earth much faster than we could in a lab on the ground. What's also unique about this mission is that CRS-33 will help maintain the station's orbital altitude that Bill was also speaking a bit about during its 5-month stay. So thanks for that orbital mechanics primer, Bill, and I'm happy to talk about the hardware as well if you have any questions about it. This is a new capability for Dragon in our trunk. And I know we talked about this some during our recent briefings, but as I shared then, it will be carrying more propellant and a few extra Draco engines in the trunk that will perform a series of burns of the integrated Dragon to ISS stack to help the space station maintain its current altitude. So it's been exciting for us to support this critical new effort, and it feels like we get to become an even more integrated part of the ISS operations ecosystem. So thanks for that opportunity, NASA. Everything's looking good for launch on Sunday. Dragon arrived at the hangar at Pad 40 last weekend. It was mated to Falcon 9, and it rolled out to the pad yesterday. Teams have actually loaded quite a bit of the late load cargo already. They're out at the pad now doing that loading operation and finishing up the final launch preps now. So we'll continue to keep an eye on the weather, but as we often say, we'll only fly when we're ready, and we're teeing up for launch Sunday morning. We're excited and honored to continue to support all of the critical work on board the space station, and we're looking forward to Sunday's launch. So thanks for having me today, and we'll look forward to your questions.
Thank you very much to Bill Spetch, Heidi Paris, and Sarah Walker, our moderators for today, joining us and giving us great insight on the upcoming launch of NASA SpaceX Commercial Resupply Services Mission, the 33rd, to the International Space Station. We'll now open it up to media question and answers. If you wish to ask a question, those dialed in, please use *1. And if you wish to withdraw your question, please use *2. We'll go ahead and start things off with Will Robinson-Smith of Spaceflight Now.
Hey, thanks for taking the time to talk with us today. A couple of quick ones for Sarah regarding the additional boost kit. Can you sort of give us some numbers as far as the size and the additional mass that this represents, adding on to Dragon, and how much propellant is on board? And also, will there be any photos or video shared of this boost kit so we can get a more visual idea of what this looks like? Thanks.
Hey, sure. So it's basically replacing a drop-in replacement of where we would normally carry unpressurized cargo payloads, 1, 2, 3 unpressurized cargo payloads that go in the trunk and then get placed by the robotic arm to the outside of space station. So we filled that trunk volume with this boost kit, as we call it. The few specifics on the modifications that we made. So overall, the structure is the same, but we did have to add a couple attach points to the insides of the trunk to mount this propulsion system to. And those will actually be just added to all our trunks going forward, just a common design. So if NASA ever wants to fly another boost mission, it will be a more seamless integration. And then the propulsion system design is influenced by our current Dragon fleet of propellant tanks and Draco engines, but it does have a unique design to support the boost. So there's a combination of both flight-proven hardware and brand new units. We actually flew these propellant tanks that are a part of the boost kit during Dragon's in-flight abort test in January 2020. And then the Draco engines flew on the Crew 8 mission a year or two ago. So those are all mounted to this cargo rack assembly that we would normally mount unpressurized payloads to. And specifically, it added 6 propellant tanks, 1 pressurant tank, 2 Draco engines, and a new heater and an insulation system to address the thermal considerations when these engines are firing for prolonged periods of time. We had to add some thermal blankets to the bottom of the section of the trunk to protect from Draco engine pluming. And then we added some additional communication lines through the, we took some spare comm channels that already existed on Dragon and we routed them through the umbilical connections in the claw down to the trunk so that we could talk to the boost kit. So it's a little bit more detail about the hardware modifications. And we actually did, I think Bill mentioned, we did some demonstrations on CRS-33 where we learned a lot, but we were just using our capsule Draco engines, using some extra propellant that we didn't need during the mission, and got a lot of useful data on how all this works. But our capsule engines are not pointed in the right direction for optimum boost, and so this trunk module has engines pointed in the right direction to maximize efficiency of propellant usage. So I hope that answers your question.
And just to add on to that, just to give you an idea of scale, so when we talk about the amount of reboost that we plan to do with this boost kit, it's pretty close to about 1.5 times a single Progress vehicle that would come up and do reboost for ISS. So Roscosmos flies Progress resupply vehicles with a certain amount of propellant in them. This boost kit will give us about 1.5 of those in terms of capability.
Oh, and I'm sorry, you also asked about pictures. Yes, tune into the launch webcast. We'll share some things during the webcast.
Thank you very much for your question. We'll now continue with Jeff Faust of Space News.
Good morning. To follow on to Will's question, how much of the ISS reboost needs will CRS-33 provide during its course of the stay of the station? Will it handle all of it, or will the station thrusters or Progress handle some as well? And then also, will this be a one-off flight, or do you expect to fly future Dragon missions with this reboost kit? Thanks.
Yeah, so it's going to handle the vast majority of our reboost while it's here. We've meticulously planned out these reboost times with the entire partnership because it's important for where it sets up the ISS for all the visiting vehicles to come to it. And so we have this one planned out really closely. I don't have an exact percentage for you. We do have one or two reboost plan with the normal Progress reboost capabilities during this period, but the vast majority of it will be handled by this particular one. Beyond this one, we haven't created any plans for another one at this point in time. We continue to monitor where we are for propellant reserves on board, and we continue to watch our planning as we go forward over the years. And so, while I won't close the door on anything, obviously we don't have anything planned as a follow-on for this one right now.
And Bill, what I had heard from the teams is that how much velocity added every year. We talk in terms of meters per second delta V, which is changing the velocity of station, which enables it to stay in orbit. I think it varies quite a bit based on the solar cycle and how much drag that solar activity is imparting on ISS, but something on the order of 35 or 40 meters per second in a year. We provide just under 10. So I think your teams have timed these burns, like you said, quite meticulously to maximize the efficiency of when and how the burn to cover your needs. But it's a third to fourth of what I think the need is during this high solar cycle.
Yeah, that's a good add, Sarah. The solar cycle, the sun goes through an 11-year cycle, and when it gets to its peak, which we've actually just been coming out of, the atmosphere actually kind of puffs out and causes more drag on the International Space Station. So we have to do more reboost in these times of high solar activity. Now it's starting to drop off, so those needs are going to drop off with it as we're on the back end of that this most recent solar cycle.
Thank you very much for that question. And again, for those media members that are tuned in, if you wish to ask a question, please use *1 to enter the queue and *2 to withdraw if your question has already been answered. We'll now go to Manuel Mazzanti of Exploración Espacial.
Thank you so much. Manuel Mazzanti, Exploración Espacial. A question for Heidi. regarding the 3D bioprinting. I'm curious to know, how do you produce those implant devices? Are you using a new kind of machine that is already on the station, that is on board, or because I'm assuming you're not using the 3D printing machine that has been being used for several years now. So I would like to have more details about those. Thank you.
Yeah, thanks for the question. As I think you're alluding to, we have done a number of experiments related to 3D bioprinting over the past few years, and they've used different mechanisms to do that. Right, the one that we specifically talked about today, in-spa auxilium bioprinting, is using a special machine that's been used, I think, once before on a previous flight. It's called the auxilium microfabrication platform, and it basically operates inside of the Space Tango. It's called their Mambo facility, which is a relatively new research facility on board. They basically send up these print cartridges. They launch them in ambient soft stowage. They insert the print cartridges into the auxilium microfabrication platform, and then the system takes over, and it's a fairly automated process. And so once those systems are bioprinted, then they're put back into conditioned stowage and returned to the ground for analysis.
Thank you very much for that question. We'll now turn to Ryan Catton of NASA Spaceflight.com.
Hey, thanks for doing this. Sarah spoke earlier to the first Dragon mission where you had to fly around the ISS first. I'm just wondering if there's any similar kind of proving you'll be doing with this new boost trunk before you reach the ISS. Will you be doing any kind of checkouts in low Earth orbit, or maybe doing some tests when you get closer to the station before you actually go ahead with the docking? Thanks.
Hey, so we got a number of test objectives accomplished on a previous cargo mission, CRS-33, as I mentioned, using the capsule propellant system. But a couple of things we wanted to learn there. One was correlating how much delta V could actually be imparted with a given amount of propellant and burn time and all the characteristics we control. How heavy is ISS really? How does the size and shape of it affect how efficient that propellant usage is? And so we got some good data on that. And then we also were able to ground our integrated models that we worked together with NASA on the dynamic loads that would be imparted on the station during the burn itself. Obviously, the burn is kind of from a single point or a single location. And so there's a big space station that then has distributed loads throughout it. So we've gotten a lot of data there. And then we've checked out the hardware of this boost kit itself through our standard ground tests before flight, pre-flight, to exercise all of those systems. So a combination of those two things, I think we've learned what we need to do. And then we will get up on station, we'll turn it on, do some minor checkouts or priming of the system before the first burn, which I believe is currently planned for September. And then you'll see burns periodically throughout the fall. This is our first long-duration CRS mission. It'll be up there, I think, about 5.5 months in order to space out the burns around the timing of when ISS needed them. And so you'll see those burns happening periodically throughout the fall.
Thank you very much for that question. And our final question for today's press conference will be with Ken Kramer of Space Up Close. Ken?
Hey, thank you for doing this, and congratulations to SpaceX this morning on that beautiful X-37B launch. So I'd like to follow up on the reboost capabilities. Can you tell me, would it be possible on a future flight for Dragon to take over completely the reboost capabilities, since you're doing such a lengthy reboost on this mission? And related to that, for NASA, can you tell us when do you stop needing the progress, right? I think at some point you're going to let the ISS orbit decay on its own, and I'd like to know when that is. Thank you.
If we went to a future capability, there's nothing that prevents us from doing the total reboost that's allowed based on the amount of propellant we could put in a boost kit. So from that standpoint, I feel like we will still split it up between our various assets, as we always do. We try to best balance our capabilities across multiple assets and keep everything working. We don't really hit a time where we stop needing resupply. We will hit a time where we start decaying down for final deorbit. From our altitude where we're at today, it takes about 2 years to decay down to get to where we want to be for a final deorbit ISS. So while we still have to do some maintenance, we still have to do some targeting of the altitudes for vehicles docking and those kinds of things, but we'll see much less reboost required in that time frame once we decide to actually start our way down. There's a number of conditions that we do have to hit as well within that. Right now, the propellant tanks on board ISS are not full. As we just talked about, right? We've been through the peak of the solar cycle here, and we plan enough to get us through that with margin, but it doesn't keep our tanks full. So we're going to be working on refilling the tanks over the next couple of years, and this mission is actually helping us to do that. So we still have a little ways to go on that, and then once we are ready to finally start drawing down the altitude of the ISS, it'll take us about 2 years to naturally decay down to the point where we're ready for a deorbit.
Is that in 2028 when that starts?
Like I said, once we decide when we'll do it, then there's going to be a lot of things that we have to look at for when we start that actual decay down. Readiness of the U.S. deorbit vehicle. Do we have the prop tanks full on board, because we require that for capability as well as any contingencies that can come up. There are a lot of factors that play into that, so we'll assess that as we get closer, and we'll pick a date then based on what our needs are and our actual delivery schedules are.
Thank you.
And maybe since I heard this was the last question, maybe I could just add. So we, as Bill said, from a capability standpoint, this boost trunk is modular, and we could send as many of these 9 meter per second, boosts up that ISS needs. But from zooming out a little bit, I actually think the sharing of capability across different resources has been one of the most beautiful things about the international collaboration of ISS. It was designed to be intentionally interdependent between different nations. Different parts and modules of the space station have different capabilities, from the propulsive altitude maintenance to the solar arrays and batteries providing power to the station to the food supplies. Everything is this really beautiful organic partnership. And so as an outside observer, it's been really neat to see that aspect. And I think the sharing of keeping ISS at the altitude it needs to be at is one of the best examples of that collaborative effort. So happy to be one of many that provide that capability.
Thank you very much for that question and those insights. And that'll conclude today's teleconference. A big thank you to Bill Spetch, Operations Integrations Manager of the International Space Station Program, Heidi Paris, Associated Program Scientist, NASA's International Space Station Program Research Office, and Sarah Walker, Director of Dragon Mission Management with SpaceX. And again, thank you for tuning in to learn more about NASA's SpaceX 33rd Commercial Resupply Services mission to the International Space Station. Again, launch targeting for 2:45 a.m. Eastern this coming Sunday, August 24th. And that'll deliver more than 5,000 pounds of supplies, including the reboost kit that we've been talking about here today. You can watch that launch on arrival coverage as well on NASA Plus, Netflix, Amazon Prime, and more. And you can learn more about how to watch that NASA content through a variety of platforms, including social media. And NASA's live launch coverage will begin at 2:25 a.m. Eastern on August 24th. And we will also have Dragon's arrival coverage that'll begin at 6 a.m. on Monday, August 25th. Thank you very much for joining us today.